In this video, we're talking about one-sided limits, and when we say one-sided limits, we mean left and right-hand limits, or the limit of a function as we approach from the left or negative side or the right or positive side. So let's distinguish between one-sided limits and the general limit. At any given point, let's say we want to take the limit of this function as x approaches the number 4. So maybe let's say the limit as x goes to 4 of the function f of x that we've been given. So square root x times quantity 5 minus x. So we want to take the limit of this function as x goes to 4. If you see this, we're talking just about the general limit as x approaches 4. But that's different than the left-hand limit and the right-hand limit. So if we want to say the left-hand limit as x goes to 4, what we do is we say the limit as x approaches 4 from the left-hand or negative side. And we write this little negative sign here in the place of like an exponent. So we're saying as x goes to 4 from the negative side or the left-hand side. So if you think about the x-axis over here, we have this point x equals 4 right here. So this is the point that we're approaching, the value of x that we're approaching. We can approach it from the negative side of the x-axis or the left-hand side. So if we're coming in this way, we're moving left to right, we're coming from the negative side toward x equals 4. That's the limit as x approaches 4 from the negative side or the left-hand limit, and we could take that limit of the same function, and that would be different than the limit as x approaches 4 from the positive side of the same function. If we approach from the positive side, we're approaching from the right-hand side because this is the positive end of the x-axis. So we're approaching from the positive end, we're approaching from the right, we're moving right to left, so that's the right-hand limit. So we have three different limits, all as we get close to this value, x equals 4. And again, this second limit here, this is the left-hand limit, or the limit as we approach from the left-hand side. This is the right-hand limit, or the limit as we approach from the right-hand side. This first limit is the general limit, and it's important to remember that the general limit cannot possibly exist unless three conditions are met. The left-hand limit exists, number one. Number two, the right-hand limit exists. And number three, the left and the right-hand limit are equal to each other. Now, when we're talking about general limits like this, oftentimes we just take for granted before we learn about left and right-hand limits or one-sided limits, we just take for granted that the general limit exists without going through the definition. But truly, the general limit can't exist unless the left-hand limit and the right-hand limit both exist and the values of these limits are equal to one another. If those three things are all true, then the general limit can exist and we can find the value of the general limit, the limit as x approaches 4. Now, if we want to take a graphical look at what we're talking about here, let's go ahead and graph this function f of x. We have f of x equals the square root of x times quantity 5 minus x. We could just plug in a few points to graph this function. So if x is equal to 0, inside the square root here we have 5 minus 0, which is 5. 5 times 0, we get 0. So we have the point 0, 0 on our function f of x. If we look at x equals 1, here we have 5 minus 1, which is 4. 4 times 1 is 4. The square root of 4 is 2. So we have the point 1, 2 right here. If we look at the point x equals 4, we have 5 minus 4 is 1. 4 times 1 is 4. The square root of 4 is 2. So we have the point 4, 2. And if we look at the point x equals 5, then we can see that we get 5 minus 5 is 0. 5 times 0 is 0. So again, we have this point 0. So what we could see is that our graph is going to look something like this, the curve or the half circle that connects all of these points. If we plugged in a negative value for x, here's what we'd get. Let's say we take negative 1. We'd have 5 minus a negative 1, which is 5 plus 1, or 6. So we'd have 6 times a negative 1, that'd be negative 6. The square root of negative 6 is something that we can't take without imaginary numbers. So x equals negative 1 does not exist in the domain of this function, which is why we can see that the graph stops here at x equals 0. Similarly, if we take a value for x that's greater than 5, like x equals 6 right here, and we plug that in, we get 5 minus 6, which is a negative 1. 6 times a negative 1 gives us a negative 6, and again, we're trying to take the square root of negative 6, the square root of a negative number, which is why x equals 6 is also not in the domain of the function. So this is the graph of our function. It only exists on the interval x equals 0 to x equals 5. So we have a couple of different interesting points. If we stick with this example here and we're interested in the limit as x approaches 4, first let's deal with the left-hand limit as x approaches 4, or the limit as x goes to 4 from the negative or left-hand side. Well, in that case, what we're doing is we're tracing the graph from left to right as we get close to this line here, x equals 4. So we're interested in the value of the function as we trace the graph from the left-hand side, from left to right, and we get close to this line. So we trace the graph and we get close to this line. What we can see is that the value that we're approaching is this point right here, which we know is the point 4, 2. The value of the function as we get close to this line is 2. So we can say that the left-hand limit here is equal to 2. Similarly, the right-hand limit as x gets close to 4, so as we approach this line, x equals 4, from the positive or right-hand side, what we're doing is we're tracing along the graph close to it like this, getting close to x equals 4, and as we get closer and closer to this point, we get closer and closer to this point here, 4, 2. The value of the function there is 2, so the right-hand limit is also 2. So we can say that the left-hand limit exists and is equal to 2. The right-hand limit exists and is equal to 2. Since both the left and the right-hand limit exist and they're equal to one another, that means that the general limit also exists, and the general limit is going to be equal to the value we found for the left and the right-hand limit. So the general limit is also 2. And of course that makes sense because the easiest way to solve a limit is with substitution, assuming that the function is continuous at that point. And if we were to just plug in the value x equals 4, we get 5 minus 4, which is 1. 4 times 1 is 4. The square root of 4 is 2. The value of the function there is 2. So we can say that the general limit is going to be equal to 2. But what if we're interested in the limit of this function as x approaches 5? So the line x equals 5 is this line right here, and we can see that the domain of the function ends at the line x equals 5. What can we say about the limit of the function at this point, more specifically the general limit, the left-hand limit, and the right-hand limit? Well, remember, the general limit is only going to exist if both the left and the right-hand limits exist, so let's look at those first. If we look at the left-hand limit as x approaches 5, so we're getting closer and closer to the line x equals 5, we trace the graph, we're coming from the left-hand side. So we're coming from the left-hand side, we're moving left to right, we're approaching the line x equals 5. Well, as we get closer and closer to the line x equals 5, we get closer and closer to this point here, the point 5, 0. So what we could say is that the limit as x approaches 5 from the negative side, or the left-hand limit at x equals 5, that is going to be equal to 0 because we're getting closer and closer to the value y equals 0, this point right here. But what about the right-hand limit? What if we want to know the limit as x approaches 5 from the positive side? Well, you can see that everything to the right of x equals 5 is not in the domain of this function. There is no graph of the function to the right of x equals 5. Therefore, we can't approach x equals 5 along the graph on the right-hand side here. So there is no right-hand limit of the function at that point, so we can say that this limit does not exist, and we abbreviate that with DNE. So the right-hand limit as x goes to 5 does not exist, even though the left-hand limit as x goes to 5 is equal to 0. So in this case, we can say that the general limit, the limit as x approaches 5 of our function f of x, is going to be DNE does not exist, because even though the left-hand limit exists, the right-hand limit does not, and because the right-hand limit doesn't exist, the general limit can't exist either, because remember, the general limit only exists if both the left and the right-hand limits exist and if they're equal to one another. So what we can say is that the limit as x approaches 5 of this function does not exist. If we wanted to take the limit as x goes to 5, the best we can do is say that the left-hand limit exists, that the limit as x goes to 5 from the left-hand or negative side is equal to 0, but the right-hand limit and the general limit don't exist at that point. So that's the difference between a general limit and one-sided limits, and how to find the one-sided limits of a function at a particular point.